Welcome to this explainer. Today, we're basically acting as cosmic detectives. We are going to completely unpack the science, the downright ingenious methods, and the mind-blowing discoveries that are driving humanity's search for alien worlds. I absolutely love this topic because it takes us right to the very edge of what we currently know about our universe, and we are going to break the whole thing down step by step.
For centuries, humans have looked up at the night sky and asked this single, profound question. It's the ultimate mystery box for our investigation today. I mean, think about it. There are roughly more stars in the universe than there are grains of sand on literally all of Earth's beaches. With those kinds of staggering numbers scattered across the cosmos, it just seems incredibly unlikely that our little blue marble is the only place where life actually exists.
And this number right here brilliantly illustrates why that question is more relevant right now than ever before. Growing up, we all learned that our solar system only has 8 planets, right? But as we've started looking out into the vast darkness across the universe, scientists have now confirmed thousands of other planets out there. The sheer scale of what we are dealing with is absolutely staggering.
So here is our cosmic map for today. 1. Are we alone? 2. Finding hidden worlds. 3. A universe of planets. 4. The Goldilocks zone. And finally, 5. The future of discovery. Let's dive right in.
Okay, starting with Section 1, are we alone? The big question.
To truly grasp this mystery, we first need to define our prime subject, which is the exoplanet. Simply put, an exoplanet is just a planet that orbits a star other than our own Sun. Now, the ones we've confirmed so far are not just carbon copies of Earth either. They vary wildly in size, composition, and environment. We're talking everything from small, rocky, Earth-like worlds to massive, swirling gas giants.
Which brings us to Section 2, Finding Hidden Worlds, Tools of the Trade. We have to ask a very practical question here. How do scientists actually find these things? Remember, they are incredibly far away, and their faint presence is completely blinded by the glaring, brilliant light of their host stars. Because of that glare, scientists have to get creative. The transit method is hugely successful. Think of it kind of like watching a tiny moth pass over a blinding spotlight. When the planet crosses in front of the star, scientists can actually measure a tiny dip in brightness. Or they look for a star's wobble using radial velocity. That's caused by the gravity of an orbiting planet pulling on the star like an invisible leash. Rarely, we can capture actual pictures through direct imaging, and perhaps the most mind-bending method is gravitational microlensing, where a passing planet's gravity literally acts like a magnifying glass, bending the light of a distant star behind it to reveal its hidden presence. Moving on to Section 3, a universe of planets, the lineup.
Now that we know the forensic tools of the trade, let's look at the incredible lineup of suspects we've actually discovered out there in the dark. And wow, the diversity out there is wild. We have terrestrial, rocky planets, much like our own, and massive gas giants like Jupiter. But we also have things completely alien to our solar system. Take super-Earths, which sit uniquely between Earth and Neptune in size. There are even hot Jupiters. These are massive gas giants locked in dangerously tight orbits around their stars, and ocean worlds covered almost entirely by deep global seas. Every single type of planet offers unique clues about how planetary systems form and evolve over time.
And that leads us to Section 4, the Goldilocks zone, the prime suspects.
Let's see how this incredible lineup builds our search for actual extraterrestrial life. The crucial point here is that liquid water is absolutely essential for life as we know it, period. And that brings us to the habitable zone, affectionately known as the Goldilocks zone. This is the specific region around a star where the temperature is just right. Not too hot that water boils away, and not too cold that it freezes solid. Finding planets sitting right in this specific temperature zone makes them our absolute prime candidates for hosting life.
But hold on a second, because finding a planet in the right zone is just the beginning. A planet must also pass a really strict habitability checklist. The temperature obviously needs to support liquid water, sure, but to keep that water from just boiling off into space, it needs an atmosphere to maintain pressure and regulate heat. And how do you protect an atmosphere? Well, you need a magnetic field acting as a giant shield against harmful cosmic rays. Finally, none of this matters if you don't have a stable star. A sun that frequently blasts out massive solar flares would strip all of these life-supporting conditions away in an instant.
Now, we've actually found suspects that meet these criteria, which is super exciting. Take Kepler 452b, often called Earth's cousin, or Proxima Centauri b, which is the absolute closest exoplanet to Earth. And we definitely cannot forget the TRAPPIST-1 system,
This is a jackpot of multiple Earth-sized planets packed so tightly together that if you stood on one, the neighboring planets would look like massive glowing moons in the night sky. I mean, how cool is that? These specific discoveries raise absolutely thrilling possibilities about life beyond our home.
All right, Section 5, the future of discovery, the ongoing investigation.
For our final piece of the puzzle, let's examine the incredible tech pushing us forward, the hurdles standing in our way, and ultimately why this entire investigation matters to you. Now, while the sheer numbers of galaxies, stars, and planets strongly suggest life could exist out there, we have to look at the facts impartially. As of right now, science has not yet found direct evidence of extraterrestrial life. No aliens yet.
However, we're closing in using highly advanced tech. We're deploying incredibly powerful space telescopes specifically designed to study planetary atmospheres in just stunning detail, and then using spectroscopy to analyze that light for biological gases like oxygen or methane. We're even scanning the cosmos for radio signals, just in case there's intelligent communication out there. And to make sense of all this, we're increasingly relying on AI to crunch the massive, overwhelming amounts of data these tools pull in every single day.
But let's be real, the investigation still faces massive hurdles. The primary issue is the mind-boggling distances involved. We are talking light years away. That means extremely limited direct observation. And even when we catch a promising whiff of something like methane, there's an extreme difficulty in definitively proving it's from alien microbes, rather than just a natural geological process like a volcano erupting.
So you might be wondering, with all these challenges, why dedicate so much effort to this? Well, this entire scientific pursuit matters deeply. By studying other worlds, we actually learn more about Earth's own uniqueness. We gain a much better understanding of how planets form in the first place. We keep the door open to exploring the possibility of life elsewhere. And, perhaps most importantly, we inspire humanity's future in space exploration. Looking ahead, scientists remain highly optimistic. They truly believe that in the coming decades, we might actually detect signs of microbial life. We might find Earth-like planets with truly breathable atmospheres. And we are actively laying the groundwork right now for future space missions that could eventually explore these nearby star systems firsthand.
And so, we return to the mystery box we started with. Are we alone? The universe is vast, it's mysterious, and it is full of possibilities. Every single new exoplanet we discover brings us one step closer to answering this ultimate question, leaving us to wonder, what exactly is waiting for us right now, out there among the stars? Keep looking up, and thanks so much for joining me for this explainer.